In one of my previous videos that was actually on another channel, I uploaded a video where we wanted to find the integral of arctan x, or the inverse tangent of x. And for some reason, the audio did not work, so I thought to myself, let's just film it again and upload it to this channel, because it is quite an interesting integral, and there is an interesting method to it. So let's go ahead and let's get started, and let me introduce you guys to what we will be using, and that is integration by parts, IBP, integration by parts. And if you don't know what integration by parts is it's basically the reverse to a product rule, where we sort of just assume a u and a v prime. And the best way to do this is actually allow u to equal arctangent of x itself. And we allow v prime to be nothing but 1. Interesting, right? And now we use the fact that we want to find the integral of this, which is the integral of uv prime is equal to uv, take away the integral of vu prime. And now we want to find u prime in this case. And u prime in this case is nothing but 1 over 1 plus x squared, which can be, the proof could be found in a previous video that I've done on my previous channel, but I might do another proof just to keep everything mathematically based on my one channel, basically. But basically you just use a bunch of trigonometric identities. And now if we apply this rule here, well, we get nothing but x arctangent of x, take away the integral of x over 1 plus x squared dx. And now we actually have a pretty simple integral to solve, which is just a u substitution. So we go x tangent of x, take away, and if we allow u to equal 1 plus x squared, then we get du is nothing but 2x dx. And now we can rearrange for x dx by dividing both sides by 2. So we get a half of the integral of 1 over u du. Okay? And in the result, we get arc, and that should be arc tangent of x there, multiplied by the arc tangent of x, take away the half of the natural log of u, plus c, and substituting back in u, we get x multiplied by the arc of tangent x, take away a half of the natural log of 1 plus x squared plus c. And you might be wondering, don't we have to use the absolute value? In this case, yes, if you have the natural log of u, but in fact, we have 1 plus x squared, which is always positive, so we don't need to have the absolute value. We can just drop it. And that is our first integral done. And in the next little integration video, I will be looking at I is equal to the integral of the arc sine of x dx and e to the I. Okay? So I'll see you guys then.